I want to give you a quick tip for finding maybe subtle tuning problems or tuning issues with Blackbox. I have an issue I'm trying to track down where when I cut the throttle rapidly, the copter loses a little bit of stability. And I can make it happen, on in testing by just doing a straight full throttle punch out and then slamming the throttle all the way down. But it doesn't manifest very much in real flight. And so I'm still trying to dig into it and figure out what's wrong. But I thought this was a good example of how you can try and find the more subtle cases of that while you're flying. Now take a look what I've done here. I've got RC command and the gyro set up on the same graph, and I've done that for roll, and I've done that for pitch, because those are the two axes. I could put yaw up there as well, but I run out of space. I've also got the throttle up on its own graph because I'm trying to look for throttle-related instability, but you don't really need the throttle graph. You can have it if that's what you're trying to troubleshoot. And what I want to look at is that as RC command moves, the gyro moves with it. It doesn't have to move the exact same amount. Don't worry, don't get hung up on the size of the move. Let me get the throttle out of there for now so I get a little more space to work with. There, you make those a little bigger. So as the RC command moves, the gyro moves the same direction. And as RC command returns to center, the gyro returns to center. Okay? Now here's a relatively big move. RC command goes up, the gyro goes up. And then as I go through the move, RC command zeroes out again, but notice that the gyro continues and moves the other direction. So the copter is now rolling the opposite direction when it wasn't commanded to do it. And anytime you see a discontinuity like that, that's a potential tuning issue that you might want to look at. Now, the copter is not flying in a perfectly still environment. It's flying in a very dynamic environment. And of course, there's only so much perfection that we can expect. But anytime you're looking and you see RC command go to 0, but the gyro continues the other direction or doesn't get to 0 basically, then that's a potential tuning issue for you to look at. Now notice that although the gyro overshoots a little bit here, it quickly gets back to 0. And this is not really something, oh, we got a problem here. Nevertheless, it could be a problem if it was more dramatic or extreme. And again, here, RC command goes up, gyro goes up, RC command starts dropping, gyro starts dropping, RC command goes to 0, gyro quickly goes to 0. Now that's nice, and gyro stays at 0. RC command goes negative, gyro goes negative. Still happening. RC command goes to 0, gyro goes to 0. That's good. That's a good tune. The more of that we see, the better the tune is. And the more discontinuity we see, like this, where RC command is 0, but the gyro is not 0, the more potential problems there are with the tune. Can we look at the pitch axis? What do we see on the pitch axis? They're corresponding. Let's look for examples where they don't correspond. Oh, here's a cross of the axis. See how they cross the axis almost at the same time? Very good. That's good. Yep. Not pitch axis looks really good. What about the roll axis? Do we have any more examples on the roll axis? Not so much. So this is suggesting that overall this tune is pretty decent. Oh, here's another example. RC command 0, roll is not quite 0. So maybe I need to look at my tune a little bit on the roll axis and see if I could clean that up, or maybe I should not nitpick so much and I should just get out and fly. But the more extreme those discontinuities are, the more I would say that there's an issue with the tune that maybe needs to be looked at. Let's take a look at the yaw axis real quick and see how the yaw axis is doing. I'm going to add custom graph, RC command yaw, and gyro yaw. Okay. The gyro is noisier on yaw on this copter. So we already see a little bit noisier, more noise. That's okay. They are staying roughly together. Let's go into a big turn now. Here comes a big turn. They stay mostly together. Mostly together. This is good. I like this. RC command goes to 0. Gyro goes to 0. That's good. They're staying mostly together. Again, zeros out together. I'm pretty happy with this. A little bit of discontinuity here. This is a little, see how the gyro is just a little below the axis, even though the yaw is basically centered. So it's potentially a little bit of nitpicky tuning I could do. Again, let's see. Oh, I'll drop out there. Goes to zero, goes to zero. They go together. So when the gyro and RC command are moving together, that's a sign of a good tune. And I especially want to look at the zero. When RC command returns to zero after doing a move, I want to see the gyro pretty quickly getting back to zero as well, because that's just a sort of an absolute, like we know zero is an absolute that we can reference against, whereas here, like what are the values here? I don't know. What are they supposed to be? I don't know. But I know that when the stick goes to center and RC command goes to zero, the gyro should be zero too. And so that can give you a sort of a tool, a general tool for assessing the sort of general goodness of your tune on any given axis. Hope that's helpful, and happy flying.